Okay, this video is all about how to solve concentrations or molarity. So concentration you might think of as I am concentrating on this video right now to get notes and to answer the questions. But really concentration is looking at the amount of stuff dissolved in liquid. I can look at it like this. I know there's a lot of stuff dissolved in this one because there is a dark color. Well, if something's diluted, there's not a lot to it. There's probably just a little bit of stuff dissolved in there. So concentrated is like when you go to the store and you get concentrated juice. You normally have to add water to it. Or a lot of soaps are that way. That's why like Tide Pods, even though they're tiny, have a lot of soap to them because it's pure of the soap. No water, not much water added. So when we talk about concentration, another word for it is molarity. So molarity is the ratio of moles of solute to liters of solution. And this is our equation. So molarity is represented by a capital M, not a lowercase m. And again, it's moles of solute of liters of solution. Let's review what solute is. Solute is the thing that is dissolved within the solution. So like salt within water or sugar in soda drinks. And then when we talk about liters of solution, that is made with the solvent. Okay, solvent is the thing that does the dissolving. Most case, it's going to be water because water is used a lot. And remember, because these things are so similar, I always remember the U in solute is you get dissolved. Then I don't get those mixed up. Okay? So let's look at this equation a little bit more in depth before we just dive into calculations. So molarity equals moles divided by liters. But in this, sometimes we are going to solve for other things. As a reminder, please keep notes about this process and things I'm talking about. I would even go back to the previous slide if you weren't keeping notes already, because then we'll talk about good notes versus bad notes. So back to molarity, which is moles divided by liters. Well, sometimes in questions, we're going to have to solve for liters, and sometimes we're going to have to solve for moles. So we can either plug in our unknowns, kind of like what we've done before with gas laws, or we can rearrange the question. Me, myself, I always rearrange it. But on the test, you're only given this equation. So to rearrange it, let's look at if we needed to solve for moles. So molarity equals moles divided by liters. If I wanted moles by themselves, that means I have to get rid of liters. So I would simply multiply both sides by liters. And I would get a new equation that liters times molarity equals moles. Or of course, let's rearrange it to mole equals liters times molarity. Sometimes we need to figure out the volume, which is liters. So we can do molarity equals moles divided by liters. And now I want liters by itself. This one's a little bit more difficult because of that. So I'm just going to do the crisscross method because anything over 1, it looks like a fraction and it doesn't change it. So let's look at that. Moles times 1, molarity times liters. So mole equals molarity times liters. Look at that. It's the same thing as here. So let's get liters by itself by dividing both sides by molarity. So liters equals moles divided by molarity. So I have 2 new equations, and that might help us out. So let's get back to actual examples. All right, so let's start with just calculating molarity. So let's do number 1 together. I'm going to do number 1 and 3. You are going to be required to do 2, 4, and 5 after watching this. Okay? All right. So number 1. It says calculate the molarities of the following solutions. All right. Number 1, we have 2.3 moles of NaCl, which is salt, and 0.45 liters of solution. So first, write your equation. As always, molarity equals moles divided by liters. Well, since here's our moles, here's our liters, this is going to be very straightforward. So molarity equals 2.3 mole divided by 0.45 liters. Put it in our calculator, and I get, after rounding, 5.1 units. Well, it's mole over liters. So you can put moles over liters, or you can put 5.1 capital M, because capital M means molarity. So either one will work for your units on these questions when you have to solve for molarity, or it can also say concentration. Since that one was straightforward, I want you to do number 2. All right, let's move on to number 3. This one's a little bit different. So we are supposed to still calculate molarity, and I have 0.09 moles of sodium sulfate and 12 milliliters of solution. Now, notice the equation is molarity equals moles divided by liters. Liters, that's very specific. So this is milliliters. So we're going to have to do something about that. Well, there are 1,000 milliliters per every 1 liter. So anytime you are given milliliters, you're just going to simply divide it by 1,000. So I'll do 12 milliliters divided by 1,000, and I get 0.012. And now that's liters. Okay, so now I can solve for molarity and just plug it all in. I'm just going to erase something so I have a little bit more space. So molarity equals mole, so 0.09 mole divided by 0.012 liters. I put that in my calculator, and I get 7.5. And I'm just going to put an M afterwards for molarity. There you go. So now you do number 4 and 5. And here's a little joke. Why did the stormtrooper buy an iPhone? He couldn't find the droid he was looking for. I know, I'm hilarious. So now it is your turn. So please do those ones. Our next question is going to be number 6. So let's look. Number 6. This is a little different, a little bit more realistic. So number 6 says how many grams of HCl, which is hydrochloric acid, are needed to make a 6M, so 6 molar is what we said. I know molar kind of sounds like it should be a tooth, but it's not. We're talking about molarity when you say molar, okay? So a 6 molar solution of HCl using 2 liters of water. Oh, little hint. A lot of times I will shorten solution by putting SOL apostrophe N, and that means solution. It's just a little shorthand. So let's look at how we would solve this question. All right. So We've been saying that we're always going to be using this. Molarity equals moles divided by liters. So here's my molarity. I have my liters, and then it wants grams. Well, grams is related to moles. A lot of times you are not going to be asked for how many moles, because think about it. In a lab, if I said, hey, can you give me 50 moles of hydrochloric acid? How are you going to measure it? Do we have a scale or anything that measures out moles? No, we don't. A lot of times we measure out our masses and grams, because a lot of things are in powdered substance that you want to dissolve into liquid. So a lot of time we're going to have to solve for moles and then convert it into grams. So I'm going to show this in two different ways, and you can write the notes based on which way you like better. So let's just say I only know this, and I just want to plug it in and solve. So molarity equals moles divided by liters. And I plug in what I know. 6 molarity equals, I do not know moles, so I'll just put an X divided by liters. There's 2 liters. So now I just need to solve for X. Again, if you like crisscross method over anything, just put molarity over 1, and there you go. So crisscross, so X equals 6 times 2 is 12. And that's molarity times liters if I want to show my units. So really that's 12. Remember, X is moles, so 12 moles. Sweet. But the question did ask for grams. So we're going to have to convert these moles into grams. So we're just going to use our conversion chart. 12 moles of hydrochloric acid. So per every 1 mole of hydrochloric acid, I need to figure out the grams. That means I have to look at the, periodic table. That's how I'll know. So 35 plus 1 is 36. All right, so then I have to just put that in my calculator because moles are gone. And that is 36 times 12. And I get 432, and this is grams of hydrochloric acid. And there's my answer. Now, I'm just going to show my other example. At the beginning, I said that mole is equal to molarity times liters. And you'll notice we kind of did that there. But if I just plug that in, mole equals 5 m times 2 liters, I still get moles equals to 12. There you go, 12 moles. Same thing. And then we'll still have to do the conversion. It's same steps. Depends on you, on what you like. Do you like to know what the equation is and just solve for it and there you go? Or do you like to plug it in and solve? Either way works. It's up to you. Now, I want you to try number 7 by yourself. So you are doing this one, and this is the one I'm going to ask about. And for your joke, what do you call a deer with no eyes? No idea. I know, I cracked myself up. Anyway, let's move on. I am going to do the last ones on each of these pages. And I suggest that you pause the video after doing your Ed puzzle question and do the rest. More practice, the better it's going to get in there. Okay? So let's start with number 1, letter D. Like I said, I'm going to do the last one because you guys always think the last one's the hardest. So we'll do that. And this one is a little bit harder because it has milliliters in there, so we're going to have to do conversion. And all of number 1 is asking what mass of the following chemicals is needed to make the solutions indicated. So it's kind of like what we did before where we have to solve for mass. Mass means grams. All right, so let's look. I'm going to write it down real quick. And there you go. So what mass of the following chemicals is needed to make the solutions indicated? Letter D. I have 100 milliliters of a 0.5 molar, that is ammonium phosphate solution. Alrighty, let's see what we gotta do. So molarity equals moles divided by liters. Again, we are solving for mass, what is closely related to moles. So a lot of times I myself, once I've shown it to you, I always just rearrange the equation. So I know moles equals molarity times liters. And then I'm going to have to convert these moles into grams. I'm just putting in a little game plan. It's good to think of why you're doing things, all right? So since it's molarity equals, or moles equals molarity times liters, well, I look at my question and it's milliliters. So I'm already going to have to change something. So I'm just going to take the 100 milliliters, divide that by 1,000, and I get that's 0.1 liters. Sweet. And now I'm just going to plug out everything in. So, plugging stuff in, I get mole equals 0.5 molarity times 0.1 liters. There we go. And I put that in my calculator. And I get 0.05 mole. But again, these questions are always going to ask about mass, because if you just told me you need 0.05 moles of ammonium phosphate, I will look at you and go, and how do you want me to measure that? Normally in grams. So now we just got to convert that. So 0.05 mole of ammonium, NH4, phosphate. Oh, lovely. So that means we need the molar mass of this. So, gotta look at the periodic table. And I'm super fast at calculating. Put that all in. And I get 149 grams per mole. All right, and that's the molar mass. So now I just multiply those two numbers together, and I'll get my answer. And I get 7.45. Well, since a lot of things have like 1, I might round this up to 7.5 grams, or I could even say 8 grams. But if my scale goes to 1 decimal place, I'm probably going to do 7.5 grams to be more accurate. And please make sure that your answer is 7.5 grams of what? NH4, 3PO4. All right. Now, on your paper, I want you to do A. All right. What's Beethoven's favorite fruit? Banana, banana. I know that's too far. Okay. Okay, so let's look at number 2. Number 2, letter C. And these ones are a little different. All of number 2 on that page, remember that page looks like this. So looking at number 2 part, let's go back. They all say we should calculate the molarity of the following solutions. So we know how to do this. Molarity equals moles divided by liters. Really simple. So let's look at C. C says we have 54 grams of calcium sulfide, CaS, and 3.0 liters of solution. What? There's no moles. There's grams, because, again, that's normally what you're going to see. So that means we're going to have to go the reverse and convert these suckers into moles first. And luckily we have liters, so that makes it a little bit more simpler. So let's start with the conversion of grams to moles. So we have 54 grams CaS. Then I have to look up the molar mass. And I get about 72 grams per 1 mole. Alrighty. So that means I do 54 divided by 72. And that is 0.75 moles. All right, now this looks more doable. I now have moles, and in the question I already have liters. So now I just plug all those in, and I should get my molarity. So 0.75 mole divided by 3 liters. Because that's what molarity equals. And I get 0.25 moles per liter, or I can write it as 0.25 molarity or molar. Either one of these works. Okay? Really simple. Now, I'm going to ask about A, but you should go ahead and do B as well. I also suggest in your own notes that you kind of make a little cheat sheet. That kind of makes it a little direct and what you need to focus on when you need to calculate these certain things. All right, and then what's the most musical part of a chicken? The drumstick. I know. Okay, so that means now I'm moving on to number 3. And this one, we are calculating the volume of each of the solutions. And we're going to keep it in liters. Nice. So I'm going to rewrite this question so I have a little bit more space. Calculate the volume of each solution in liters. All right, and I'm going to show both ways, either plugging it in and then solving, and then or arranging the equation first. So we have a 0.4 molar solution containing 290 grams of aluminum nitrate. And again, we're having to calculate the volume, which is liters. We're using this equation, molarity equals moles divided by liters. So we still need moles and we still need liters. Problem, oh, guess what? We got grams. Got to convert those things no matter what. So 290 grams of AlNO3, 3. And we are going to have to look at the periodic table for this. And after I quickly calculate it, I get about 213 grams per every 1 mole. All right, so that means I'm dividing 290. So 290 divided by 213. And I get about 1.3615, blah, blah, blah. I'm going to make it 1.4. If you want to be more accurate and use 1.36, that's fine too. So 1.4. All right, now I have moles and I'm trying to solve for liters. So on the left side, I'm going to do this where I'm just going to plug them in directly into this equation right here and solve for L, and we'll see how that works. So molarity equals moles over liters. Molarity, we said, is 0.4. And moles, we now say is 1.4. So 1.4 mole divided by liters. And I need to solve for liters. I would just do the crisscross method, put the molarity over 1, and then just cross multiply. So 1.4 equals 0.4 times liters. Or you guys can always use X, okay? I'm going to put parentheses for my multiplication because that point and that multiplication dot looks similar. All right, so then I'm trying to solve for liters, and so I need it by itself. So since they're multiplied, I have to do the opposite, meaning I'm dividing both sides by 0.4. So that my liters is going to be 1.4 divided by 0.4. And I get 3.5 liters. And that's our volume. There we go. Ta-da! So let's look at the other method. The other method, I said you arrange your equation first. And when we arranged our equations to begin with, we found out liters is just going to be moles divided by molarity. So then I just plugged it in that way. That liters equals moles was 1.4 divided by our molarity of 0.4, which is kind of what we did here. And you're still going to get 3.5 liters. So this is one reason why I like this method, because just deriving my equations first and having it at the top of my paper. Again, on the test, you're only given the molarity, but if you just only have to write 2 more equations, it will kind of save you some time and headache and maybe run into less mistakes in the long run. So again, I suggest this method of manipulating your equation first and being able to solve. All right, now I will ask you about A, but you should do B as well, just to get a little bit of practice. My joke is going to be a knock-knock joke. Knock, knock. Who's there? Sadie. Sadie who? Sadie magic word and I'll disappear. All right, so right now, really, you have all the tools you'll need to solve any question about molarity. But the rest of the packet does have word problems. So I was looking at the back, and I want to do a molarity question that doesn't look like molarity right away, which is number 17, which is asking, what is the concentration of 450 milliliter solution that contains 200 grams of iron 2 chloride? So this one is going to be a little different. And I'm just going to erase some stuff so I have plenty of time, places to write. All right. So this question and maybe other questions that we see can be a little bit confusing because it says concentration instead of molarity. But remember, concentration does just mean capital M. All right, so if I need capital M, that's moles divided by liters. So then I just read the question. 450 milliliters. Oh, that's not good. We're going to have to convert that to liters. That contains 200 grams of iron 2 chloride. Iron 2 chloride. Iron is Fe, and if that's positive 2, chloride is Cl negative. So switch our charges, and I got FeCl2. Yep. All right. Now, let's start solving, but the problem is I don't got moles or liters. So this one takes a little bit of conversions to do. So first, let's just quickly solve to liters. So 450 milliliters divided by 1,000 equals 0.45 liters. And then now I have to convert those 200 grams of iron 2 chloride, into moles. So 200 grams of FeCl2. All right. I look on the periodic table because I want to get rid of mass. It needs to come down. So about 127 is the molar mass of FeCl2 per every 1 mole. So that's 200 divided by 127. And I get about 1.574. Let's just round it up to 1.6. Oh, and that's not moles or grams, it's moles of FeCl2. All right. So now I have moles and now I have liters. So then I just plug them in. 0.45. Ooh, I almost went the wrong way. Moles divided by liters, Waldron. 1.6 moles divided by 0.45 liters. All right, so 1.6 divided by 0.45, and I get 3.5. So let's just round it up to 3.6 molarity of course, FeCl2 solution. There you go. That's how I solve. So a lot of these you just have to carefully go through. Having a good notes or like a little cheat sheet while you're going through these will help you out a lot to focus. So if you kind of get lost or lose track, you have something to remind you. So I want you to look at your notes right now. How easy are they to comprehend or to know what you need to do right away? I want you to look at mine and see the difference. And these notes that I'm about to show you are actually something I found within a lot of my old high school stuff and college stuff. And this is something that I made before. I rewrote it because it was horrible to look at. And I kind of reorganized it just a tiny bit. But check this out. These are my notes. So it has everything that I've been talking about. What concentration means, molarity, my little note about how U gets dissolved. Has everything on here. What do I need to do to solve for grams or mass and what I'm given? Because in the question, I'm always going to be given volume and a molarity. And I have all these little notes. This helps out so much while you're trying to do molarity questions. At first, just to like realize what do you need for each part. If you would like to take a picture of this or screenshot it, please do. Make your own. I will have this at my desk, so if you want to look at it in person, just ask. I am more than welcome to share my notes with you and how I always make these kind of one-pagers of information. So now you can concentrate on your molarity practice. And yes, that's my last lame joke of this one. You're welcome. Thank you for watching, and yeah.